Hello, OSHWA heads. Welcome back to another session of our monthly show and tell. We're really excited to have three new, really incredible certified projects to talk about today. But before we get to that, I do just want to give everyone a little reminder that our tickets are on sale now for the 2025 summit that will be taking place in Edinburgh, Scotland. We're looking like it's going to be a really good year. We've got some really banner projects coming in. We've got some really incredible proposals. We're sifting through about 162 proposals right now and trying to figure out how we can fit as many of them as possible. So it's always really fun to play this part of the game where we play really intense scheduling Tetris. So keep your eyes peeled for when we start to release some of the programming information, as that will be starting relatively soon. So if you did apply to present something, you should be getting some info in the next couple of weeks. We're hoping to have most of that sorted by the end of January, so keep your eyes peeled, watch those inboxes. So today we have three newly certified projects. So we've got Avinash Bhaskaran's Haptic Paddle, Mike Coates' Spy, Break and Check, and Luciano Fumagali's Angelo. So these are three really cool new projects. We're really excited to get talking about them. So we're not gonna dilly-dally. We're gonna go ahead and we're gonna bring on Avinash right now and get started. Oh, and I'm gonna add him to the stage. And hello, Avinash, how's it going?
Hello, it's going good. How's it going for you?
Not too bad. Stoked to have you here. So I will give a little disclaimer. Avinash is not only a certified creator, but he is also currently working on our open healthware initiative. We're really stoked to have him on board. He is a wealth of knowledge. So let's talk about your haptic paddle, though.
Yeah,
So,
let's talk about it. Thank you
so
for that warm introduction. Um, yeah, the haptic paddle is essentially a force feedback device. So we think of haptics, we think of things like our touchscreen in our phone that vibrates, or a smartwatch giving you an alert. And so haptics is really how humans interact with the world around them through the sensation of force and touch. And so we'll talk a little bit about that and what the haptic paddle is. I'll go ahead and share my screen now if I can.
yeah, of course. Whenever I think about haptics, I don't even think about my phone to start. I think about those really fun movie theaters that do the like 4D haptic experience where the seats like vibrate when things blow up and stuff, which is
Yeah, I
kind
think
of
that is a
fun.
better example. So that kind of, yeah, leads right into it. So, it's this idea of you're watching just a regular 2D movie or even a 3D movie, like it's separated from your physical motor neurons. And so kind of bringing those into the experience can help inform your understanding of what you're looking at. And that was our motivation for developing a haptic paddle, was to translate concepts in physics and mathematics to students. So this idea that what if you not just see the roots and poles of a differential equation or a quadratic equation, but you can feel them and touch them and feel how they pull on the system in a physical sense. So that that can kind of enhance your experience and understanding of conceptual systems, specifically in system dynamics education. So the So the project was primarily engineered by myself with collaboration of several grad students in our lab, as well as a co-I, Dr. Rylett, at Auburn University. So we had some funding support from the Council of University Transportation Centers and Auburn Transportation Research Institute. So we talked a little bit about, kind of what is sensation, what is haptics. So there are two types of nerve endings we talk about in haptic sensations. Really, there are a lot, but the two main branches are those related to tactile sensation, so measuring what physically touches your skin, and then measuring the movement of your joints. So even when you close your eyes, your body has an awareness of where your joints are because it has nerve endings in your joints. So you're at a 4D movie and your seat vibrates. So you not only got some mechanical deformation of your skin, but also of your joints as you're moving through the experience. So haptic systems try to interact with both the tactile and kind of tactile sensation as well as the proprioceptive. or the joint rotation sensing of the human body. And so engineers in my field who are developing technology to interact with humans have to consider both of these elements in how we learn and interact with the world. So, you have like adaptive steering and cruise control, like your steering wheel is physically providing you with proprioceptive information about the driving environment. So there's really a wide variety of applications in engineering and STEM. So this is a schematic diagram of the haptic paddle. So it's a paddle shape that's being driven by a DC motor to rotate around its center of mass, kind of right here. And so the idea is it provides you with a tactile sensation of holding a physical object. So, for example, if we're talking about a mass in physics and kind of the gravity it experiences as it's falling or sliding down a ramp or something, so you're physically holding onto the mass so you can feel it, and then you have a proprioceptive input from the DC motor, which is physically moving the paddle, so moving it around a range of motion. So if we're talking about the basin of a quadratic equation, you can really feel those dynamics as it arcs through its rotation. And so our goal is to develop this system as a low-cost teaching tool to simulate virtual interactions and system dynamics. So the haptic paddle actually has a long history in haptic engineering. It was first presented in '97 by Richard and Okamura, kind of a big name in haptics science in general. And so the elements it featured was that it was a low-cost system, it had a single axis of rotation, and it provided force feedback to the user. So Dr. Okamura continued to work on this throughout the years and still does. At Stanford, she introduced interaction control to the haptic paddle. So you have your haptic paddle system here and a load cell, which measures the tactile input. So when you're holding it and touching it, how much force is your skin feeling at your fingertips? So at Rice University, which is kind of getting closer to my interaction with the haptic paddle, I grew up in Texas, went to school in Texas. The rapid prototyping element was introduced by a team at Rice, where they were able to laser cut all the materials at a low cost and with high accuracy and precision. So essentially, as the years progressed, we were able to enhance it so that anyone could purchase these parts and assemble it at home with that precision equipment. And so what they were also able to do is to actually study educational outcomes. So they used the haptic paddle in system dynamics classes and provided students with reflective assignments. So, what did you learn about this? What did you learn about physics concepts? Can you try to answer this question about physics now that you've experienced the system physically? And they were able to show improved educational outcomes, not only in the US, but also in Switzerland and other places like that. And so also at Rice, this is some of the work that my PhD advisor did, was to introduce friction transmission. So the previous designs used, let's see if I can find a good picture. It uses a very thin cable. I actually don't know if my mouse is showing up, but in the bottom right image, you can see a very thin cable by the word thermal insulator. And the DC motor is winding this cable up to move the paddle back and forth. But to make that easier for people to assemble and use in their daily lives, we introduced neoprene tape and a DC motor that simply kind of rubs up against the tape in order to move it back and forth. And kind of as we really get into the more recent developments, Melissa Martinez at Stanford, I think a student advised by Dr. Okamura, developed this 3D printed haptic paddle that uses Arduino style microcontroller platform and really opened it up for community support. So Melissa Martinez was kind of the first person to bring this into the open source community and the open hardware community in its kind of early stages of the design. And so the work that I did was to introduce, kind of building upon the work that others have done, data-driven control. So the idea that we've now gone from it can simulate physics, it's easy to produce, it's low cost, now it's open source and 3D printable, And now we're introducing concepts that people are experimenting with now, like AI and reinforcement learning, so that the system can learn about physics that it doesn't know about beforehand. And so the primary contribution of our work was to introduce computational hardware to enable iterative learning control. And so what that is basically is the system collects data in real time and updates its expectation of future actions and events based on prior data. So rather than having a comprehensive model of physics a priori, posteriori, it updates its physical model. And so, in a nutshell, what that means is it's able to adapt to changes in dynamics and in the environment without an accurate system model. And this is really valuable because of, you know, well, kind of one of the things we wanted to do is simulate environments that humans don't normally interact with, like what does gravity feel like on Mars, or what does road friction feel like, when you're hydroplaning or something like that. So, in order to simulate these kind of diverse dynamics, the system kind of needs to learn about its own um, parameters at any given time. For example, the rubber on the neoprene can wear down over time, so it needs to be able to update its own model of its hardware to deliver accurate dynamics. And so kind of a fun thing we introduced was the idea that model-based control, which is kind of normally how this is done, has kind of really declined since computational hardware has accelerated so much recently, and searches for data-driven control have also increased a lot. So I think we're really hitting the nail on the head in terms of where system dynamics and physics education is going to move, which is essentially this kind of learning-enabled processes for modeling and understanding the world around us. But the problem is a lot of the hardware, especially for the haptic paddle, doesn't support data-driven control. We'll talk a little bit about why that is. So existing haptic paddles use microcontrollers with basically large ROM storage. So you flash a code and it repeats that code. It doesn't really have a place to store new data effectively. So if you wanted to record data over months and years or something, or even significant amounts of physical information about the system, to update the main process that it's running, it wouldn't be able to do that. So a lot of people are familiar with Arduino. Probably this information is a little outdated now in 2025, but when we were developing this project, Arduino didn't have good capabilities for updating the code that it's running. You'd have to stop it and then send new code. But now there are microcontrollers that allow you to do that, and so that's kind of what we're doing here. Now, obviously, the very first haptic paddle developed here used a very expensive data acquisition system, and that was par for the course back then. So we're kind of looking toward the next step of the evolution. That would be more cost-effective and efficient. And so the particular microcontroller that we tried to use was basically a Raspberry Pi inspired controller, which unfortunately there's some kind of sourcing issues around that in terms of open source, but it does, it is a commercially available hardware that anyone can purchase, and it does feature the kind of storage capacity needed to rewrite its own programming as it's running. So it's able to learn things, whereas Arduino requires a whole lot of other upgrades to learn things. So we present this, the haptic paddle. It's got an LCD screen, so it allows you to change the parameters of the environment you're wanting to work with. So you can switch it to a spring system, so it springs back and forth, or a damper, and it's very slowly moves slowly. And we also introduced planar 3D printed parts, so you can print this. It doesn't print any parts vertically; it prints everything horizontally, and then you can assemble it together. So it's a little faster and easier to produce that way. Also, you can laser cut it because it's planar. So kind of a quick diagram of how it's installed. So this is just to point out again that this is a planar construction that's faster to print and easier to assemble than traditional non-planar designs. It's very cheap. It's $50 for all the fasteners and basically all the material you need to use it. And CAD files are all available on the link in the OSHWA certification library. So as I mentioned before, it does use some microelectronics that allow it to do the data-driven control. So it's got part 8, that's the flash dominant logic board. So it's a Raspberry Pi board, a motor driver, a magnetic sensor, and a small magnet. So that's how it tells where its position is. And of course, a DC motor and neoprene that allows it to spin the paddle. So there are some technical details on the precision and capabilities of the microelectronics. I hesitate to dive too deep on these because I think this is just a rapidly evolving field. So in a month, these numbers are going to be much larger and much different. So I think people can definitely look to Raspberry Pi hardware, especially new hardware like the RP2040, which is a very small microcontroller that does a lot of what Arduino and Raspberry Pi can do. It's easy to fabricate, as I mentioned, so just a couple of wires for I2C power and ground communication. And so the green part right here, this green is an open source PCB I designed. The files are also available on the GitHub. So all this can be purchased readily, commercially off the shelf. And so to validate it, we did a frequency domain experiment to prove that the bandwidth, mechanical bandwidth, so the range of frequencies that our system can represent is actually competitive and higher than the traditional haptic paddles that were designed in the past 20 years. So this means we can represent realistically features like hydroplaning and things like that. So you can review the paper that's linked in our repository for kind of more of the details of the validation, but to say that it is comparable and competitive with the capabilities of other haptic paddles. A diagram of the code is provided here. Kind of the important part is to update a neural network, which essentially is like a linear algorithm with a set of weights. Weights being like some numeric values that go in an equation. So basically, it updates the numeric values of the equation based on a gradient of a loss function, which all of this stuff can be changed and tweaked and designed by the user. Okay, I'm going to skip a slide because I want to see the graphs. Here we go. Okay. So what we did is to prove that this can actually learn things is that we added dynamics throughout the course of an experiment to watch how it changes and accommodates those dynamics. So the blue is a trajectory we wanted it to follow. And the red, going from light to dark red, is it converging to the optimal trajectory given the constraints that it has to follow. So this first graph is when we varied the effective inertia. So basically how heavy it thinks the paddle is. And so we would increase the expected weight of the paddle. And so what we found was that, as expected, it kind of has to swing wildly to meet the trajectory demands because it thinks it's very heavy. So it's trying to move a lot of mass back and forth. Then we introduced damping. So damping is like, I think people are kind of familiar with the damping. It's like a syringe, like the effect of kind of the air pressure in a syringe, or how honey is viscous. So we introduced damping, and so the light red is it's kind of like learning. Oh, okay, I've got some damping to play with now, and the dark red is as it's converging. It's like, okay, now I can use this damping to realize the trajectory more effectively. And then finally, we introduced a spring effect, and so spring effect is valuable because it allows you to reduce steady state error, kind of springing back and forth between a set point. So essentially going from the simulated to the real platform, introducing new dynamics, it was able to converge to the trajectory that we planned. So in conclusion, we advanced the state-of-the-art in haptic interfaces for system dynamics by presenting a haptic paddle that supports data-driven control, planar 3D printable design. It's convenient for beginners and undergraduates to use. I think I've used pretty much all of my time. I don't know if there are any questions.
No, it was actually very concise despite the time constraint. I feel like you really gave a lot of that information there. I think we've got time for one quick question, which is just going to be from me. I'm actually just curious about like what got you engaged with haptics, especially like what drew you to that area of study.
Yeah, that's a really good question. So I think the main thing I would point to is the idea that haptics can assist people with limited mobility. So folks who are suffering from a stroke and have limited control over their own body, folks born with cerebral palsy who just have limited mobility in walking, and haptics gives them a way to interact with the world within their own environment. And I think that's what inspired me to say, okay, there's a really transformative technology here. How do I leverage this to enhance people's quality of life? So this is an example where haptics is being used to enhance students who, don't necessarily go and interact with these physical systems every day, like a mass spring damper system. But this brings it to their environment where they can physically interact with it and get comfortable with it.
Amazing. This is really amazing to see, especially like the things that y'all have brought to this project to kind of push it beyond what haptics were doing before. I think this is going to really do some incredible work. Just getting people to understand these data-driven questions that you're bringing up in education and the academic area, but also I can definitely see some out of academia applications coming as well. So very amazing work. Thank you so much for being on today, Avinash.
Thank you. Thank you for your time.
And we're gonna send Avinash away. Bye, Avinash. And so incredible first project. We love to learn more about these types of things, especially when we're looking at open source within the academic sphere. This is an area that OSHWA has been very interested in for quite some time, just because we do see a lot of academics that really push for the idea of patenting right off the bat, or students do often get caught in these ways that academia will insist that things need to be patented or that things belong to whoever they're interning for, et cetera, et cetera. So things like this are such great ways to show that like you can very well do really important academic work and not have a patent on your work and make sure that other people can get access and create just as well as you can. So we love to see it. Next up, we've got Mike Coates, the lovely Mike Coates, joining us from Scotland. And he's going to be telling us about Spy Break Inject. How's it going, Mike?
Yeah, thanks. Okay. Overwhelmed now after seeing that presentation. I'm not sure if I can quite follow the professionalism that came along there. This is a little bit more amateur hour, but stick with it and we'll be fine. Yeah, Spy Break Inject is a small purple circuit board.
You love to see that Osh Park purple.
Yeah, it's the easiest way to get them up and running. It really is. I've got some slides to go along with this, so 2 seconds and I'll pull it in. But yeah, so the background to this is kind of one of those problems that annoys you and you just have to try and fix it no matter what. It kind of wheedles at you away in the background. And so yeah, this is Spy Break Inject. So yeah, bikes. Cycling is one of my passions. It has been for a while. And back in 2021, when the world found themselves in a very different place, the lockdowns in the UK meant that we were restricted in what we were allowed to do to go outside and all that sort of things. And one of the things we were allowed to do was we were allowed to go to the shops and we were allowed to exercise. And so I combined them together, and so we cycled to the shops. That's what we did. We did our groceries, and by doing that, I found myself a lot fitter than I had been in the past, and so I was quite into cycling, going big distances and doing big cycles. But my partner had never done that, and so it wasn't very fair if we went out on bikes together, because I was tearing away ahead because I'd had 6 months of physical practice, and she was brand new to cycling, or a very kind of early to returning to cycling, and so we went out and we bought a Van Moof e-bike, which they sold themselves as the Apple of e-bikes. It was fully integrated. It had front lights, rear lights, all running off of the internal battery from the e-bike. It has racks and panniers. It's off the shelf, perfect, do everything. You don't have to think about a bike. And one of the really clever things that it came with was it came with automatic gear shifting. So as you took off, it would be in a nice easy gear, and as you accelerated, it would skip through the gears for you, giving you extra speed, which was fantastic, really clever. However, from a company that has aspirations to be Apple, but without the budget of that, they might not be the most reliable of components. And so the gear shifter fails quite frequently. That's what one of their gear shifters looks like, because this one has failed and isn't on the bike anymore. But on the end of it is just a very small electrical cable with 4 wires on it, and that got me to thinking, well, if I can't fix it mechanically, can I at least fix it electronically? Could I build a small circuit board running off of an Arduino or something like that that could see whatever signals the bike is sending to the gear shifter, spoof enough of them to fool it into thinking it's talking to a real e-shifter, and then just carry on letting us ride the bike anyway? Because the problem is when these things fail, they fail with a big flashy error message on the bike. Like if in your car and something goes wrong, you get your check engine light, and you get your return to service center warning on these as well. Not great.
So helpful. Not
Not
so great at
particularly
all.
great when it's suspected that these are probably what caused the company to eventually go bankrupt, and so now you can't get them serviced by the main manufacturer anymore. So spare parts are becoming very hard to find. So yeah, the digging that was done was on the end of this is a small connector, and imprinted in it, which is impossible to read even in person and in good light, so I won't be able to show it on camera, is the name Higo or Hygo. And so after doing some research, it turns out that they are the manufacturer and supplier of cables for e-bikes the world over. If you go on to AliExpress or onto eBay and you buy one of those kits that upgrades your bike into becoming an e-bike, all the different types of cables and plugs and connectors come from this company, from Hygo. And so doing some digging, I managed to find the connector and find a supplier for the connector, and it turns out they come with super teeny tiny wires on them, 30 gauge wires, and so that's fine for soldering. But if you have a look at any of your screw terminals or Wago clips, things like that, most of them don't go that small, and so I ended up having to go and find a component from Worth. They're one of the only people that will do a spring terminal connector for wires that small, and so that was what the circuit board effectively got built around, was trying to get some way to tap into the signals on the bike from those super small terminals. And then, because I was having to send off for a circuit to get built, I decided to do a bit more work and try and make it a bit more useful for just the one use case. So yeah, so it went through a few iterations. I've got some of the original ones, which aren't quite as pretty. They don't have the spaghetti diagram on the front of it and the texts in plain boring KiCad default text font, because it turns out I knew nothing about getting circuit boards produced, and so I just went to OSHWA and uploaded the circuit board, and I had picked a nice pretty font on my computer, but it turns out that when you do that, KiCad doesn't actually vectorize that down, it just sends the text up, and so it replaces the fonts with that you'd carefully selected and designed with the plain normal square ones. So round 2 came back, and I'd done some nice some bit nicer silk screen and get it looking a bit more pretty. And part of that was also because on the whole open hardware and getting a license thing, this device on its own is probably too simple to be considered copyrightable, because it has no active components. All it is wires connecting to other wires, and so you couldn't probably actually copyright and license it out. But I spent significant time designing the silkscreen, so I believe that probably makes it copyrightable, because it's
So,
the artwork is copyrightable. The circuitry
yeah.
isn't, but the artwork is, and so therefore it can then be released under an open license to make sure that people can benefit from it. But yeah, so yes, this is kind of a close-up diagram of what it is and how it works. So the idea is that we've got a number of connectors on all edges of the boards. So you've got your spring terminals sitting to the left and right that allow you to do the SPI part of that. So connect the cable in, sit there, and then you can see along the bottom of that diagram, I've got a croc clip and a couple of oscilloscope probes hanging off of it. So what you can do then is, now that you're in line, you can sniff the signals from it. In that breakout in the top part, what's happening in the middle is all those wires from the left-hand side of the board to the right-hand side of the board just shunt straight the way across, but they hit that block of jumpers in the middle. So if you want to break any of those connections, you can. And so you can pull one of those jumpers off and see what happens. So in this example, we're watching the TX and RX communications go back and forth. Well, what happens if I remove the RX side of that? What happens if the response from the e-shifter back to the bike doesn't get to the bike? At what point in this communication process does the bike flash up its error message? Is it because it's noticing that something isn't putting 5 volts on a line that it should be? Is it that it's not responding to a packet of data that it should be? So you can pull these jumpers in and out to just disconnect wires live on the circuit without having to tamper around with your spring terminals or solder points or anything. You can just pull them out, and then you can kind of see what happens when you break it in the middle. It does also let you do some other interesting things as well. So you can use the terminals then. If you've actually pulled the jumper off, you could measure the current that's flowing in that circuit, because you've now got somewhere that you can inline insert your ammeter. You can always put your voltmeter across it and check the volts, but now you can also do current sensing as well, so you can check what's actually going on in the wires and what's getting drawn there. And so it's got connections for oscilloscopes down the bottom. It's got pin headers for pins and for sockets on the top. So just about anything you possibly could connect to it and sniff out the circuits you could. And so that's, yeah, this was my proof of concept with the first generation one. And this was really kind of what sparked the project starting back up again. So I'd been playing around with the VanMoof bike for a while. This wasn't the only hardware fault that the bike had. It had a battery pack that died. It had a central controller that died, but all of them were due to lithium-ion batteries being let to go cold over winter and then not being able to be smart charged afterwards. So I had to learn how to pull a battery pack apart and recharge individual cells to rebuild it all. And then I saw on Mastodon, on social media, the Glasgow digital interface was started to ship. And so I jumped on the very end of that crowdfunder and managed to get hold of one, because it's a great device for reverse engineering this sort of stuff, because it can run in analyzer mode, but it's also very forgiving on the signals that you feed into it. If you overvolt the lines, as protections in there to protect that sort of stuff, which was quite important for this project, because reading up on what other people have discovered in the past about it, the e-shifter itself is technically mechatronic. That what goes on is in the VanMoof, it has a hub gear in the back wheel, and so there's a very small cog attached to that as you turn it, that's what turns a series of gears inside the hub that allow it to shift gear. But you're talking, there's a total of a quarter of a turn to go from gear 1 all the way through to gear 4. So it's a very stiff friction fit. So you need quite a lot of power to make that move. And so one of the pins on this is 24 volts, whereas everything else is at 5 volt logic level. And so if you wire up your GPIO pin the wrong way around, you could end up sticking 24 volts through your microcontroller, which is never going to be a happy day. But the Glasgow is perfect because it's got all the protection built into it. It was designed basically for this, and so you can just slap it in line, see what the wires are doing, and away you go. So this was a proof of concept, just taking one of those DHT11 temperature humidity sensor things, hooking it up to an Arduino, and then tacking the Glasgow on the side of it to try and see if I could kind of run all the software together and sniff it all out. And then you can, from taking the Glasgow, you can export a signal trace. You can drop that into GTK Wave or into SIGROC, and then you can start parsing out the packets, and yeah, getting all the way through. And so that's been really useful. And I've gotten to the point now where I've got an actual live one hooked up with wires on the end of it that can sit in line on the bike. I can go for a ride, and I can capture the packets that are getting transmitted during the ride. I can then take them offline and fire them into PulseView and decode them. And so it turns out that it's actually talking some sort of Modbus. So there's already decoders and stuff in place for that. Now all I need to do is try and actually understand what the messages mean well enough that I can write a little firmware and then spoof the signals so that I can make a physical hardware piece to replace it. So that's the next steps on it, is to get in there and actually build this replacement, because this was just a stepping stone along the way, but it was quite fun. I mean, it's been years since I've done any PCB design. The last time I did it was when I was in college, so it was good to break out KiCad and relearn some skills.
Yeah, definitely. It's always fun to revisit something, especially now that some of those tools have been really updated to be even more.
Oh, yeah, massively.
I'm sure
I think
the difference must be incredible.
Yeah, and it's been a good kind of probably 20 years since the last time I designed a PCB. So yeah, so even just the rapid prototyping that's available through people like OSHWA and that wasn't available then. We were back in those days laying out PCBs and then UV imaging them and then etching them by hand in the etch pool at the college. So yeah, this is much cleaner, simpler, and easier to to be doing. Haven't a hand etched a PCB in a few years.
I feel like that must be. I mean, it's a specific skill that fewer and fewer people are going to know how to do. So it's cool to know that you can do it.
To know I have done it, I'm not sure I could.
Sustain knowledge of it.
Yeah.
But yeah, it's so now it's just figuring out if you can actually get this bike to acknowledge that it's not broken when you're riding.
Yeah, that's the idea, is that there appears to be, from what I've managed to log so far, I haven't managed to capture all the packets that are going back and forth yet. So there's packets that appear to be I want you to change gear. There's packets that appear to be, what gear are you currently in? And there appears to be some sort of heartbeat health check packet that comes in kind of once every few hundred milliseconds, and it's the same request all the time with the same answer all the time. So it looks like that's possibly enough to fool the bike into thinking that everything's happy. But I still need to capture the actual startup sequence, because I don't know if there's anything interesting happening that kind of is there a key exchange or any sort of information that's going to be reused as the values in those heartbeats or health checks. But yeah, I think we're pretty close to cracking it.
I feel like everyone who bought one of these bikes is going to be very thankful when you do.
I've had a couple of people ask, because I did mention it. So I run a blog, and I detailed my my teardown and rebuild of the battery. And I've had a few people asking for assistance and questions around that, because that in itself is a fairly common problem as well. And I'd mentioned once in a post that I was looking at this, that was about a year ago, and I've had somebody come back and email me within the last 3 months saying, "Did you ever get anywhere with that?" I was like, "Well, funny you should ask."
Journey.
Might be looking at that right now.
That's so fun. Especially, like this is a thing we see all the time in products that are released and then very quickly run their course and disappear, and the support is gone. So you coming in and providing that support.
There are a couple of companies on the continent who have reverse engineered it sufficiently to be able to repair them. And so you can ship it to them. They'll fix it for you and ship it back again. But that's in the realm of, if they're about kind of $150-200 to get a replacement unit on a reconditioned market. And presumably only get more expensive because there are no new ones getting made. The stock in the world is all that there is, and so yeah.
That's always fun too. I'm very familiar with. There's only so many.
Yeah.
Yeah, that'll be interesting to see how it like progresses. In the meantime, are you still able to use the bike, or?
Yeah, so you can still use it. Our one at the moment, the electronics haven't died, but the motor side of it appears to. So it's stuck in gear. If you pull it apart, you can fix it into a suitable gear. So it turns out that third gear in these bikes is actually about the sort of speed that you'd want for kind of just tootling about town. It's pretty good at that. And the electric assist has enough power that even if you're not in the lowest gear, it can still help you away from traffic lights and get you up a hill without having to change it. So fixing it into third gear isn't a bad idea.
Yeah.
But the problem is that the motor isn't completely broken, it's just mostly broken. And so you can fix it into gear, go for about a week, and then suddenly you'll be riding along and then you'll find yourself back in first gear again because it just got enough power to overcome whatever friction was stopping it, and it locks you back into first gear. And the only way to get back out is to get home, completely disassemble the bike, because you've got to literally you got to take the wheel out and then disassemble the shifter from it. And so yeah, it's like if you find yourself 10Ks from home and you can only ride in your lowest gear and you can not go any faster than 10K an hour, you're for
How
a bad
convenient.
ride home. I mean, it'll be easy, it'll just be very slow.
When you think about it, they really are the Apple of bikes, because you also can't repair your phone that well either.
Yeah.
I had to give them $100 to give me a new battery, and I didn't think it needed to cost that much, but I also didn't want to do it myself.
Yeah. It's they really did. Apart from the going bankrupt thing, instead of making billions.
Yeah, they went the opposite direction. If we're lucky, Apple will do the same. Thank you so much for giving us a little intro and some info on the Spy Break Inject. I'm really curious to see how other folks decide to utilize it. I'm sure other people don't just have bike problems, so I'm curious to see.
I mean, it hopefully should be reusable for other folk out there. So all the KiCad files are on my Codeberg on my repository. They're all in Git, so you can just grab them and send them to OSHWA if you want. I have a few boards left, and I'm going to make a couple more, so they might appear on a Tinty store at some point as a kit. But I mean, you can just send it straight to OSHWA. I've got bill of materials set up for DigiKey, for Mouser, for Farnell. So if you want to place a direct order, you can just copy and paste the CSV file into their thing, and they'll send you all the parts with the right quantities and things. So it's reusable, it's ready to go if anyone fancies it.
Perfect. Incredible. We love to hear it. Thank you so much for coming on today, Mike. I'm really glad we were able to make some time to hear more about Spy Break Inject. And
no, thank you. It's been lovely.
Evening in Scotland.
Evening.
All right. Goodbye, Mike. And that was really cool. I love when people fix their things. Right to repair is so important and deeply intrinsically tied with the open source movement. So seeing all the fun ways that people are finding ways to do that is so incredible, especially on bikes that seem to be weirdly unhelpful as a bike. Now we are going to bring on our final guests. We got Luciano Fumagalli, who is coming to us to talk about the Angelo. So as a little intro, Luciano is primarily an Italian speaker. So we're going to have a little document to help Luciano keep track of what he's talking about, what we're hearing, and welcome, Luciano. How's it going?
Okay, it's okay. Do you tell me?
Yep.
Okay. Start now? Okay. Allora, ciao everyone. Thanks for inviting me. My name is Luciano Fumagalli. I'm 64 years old. I'm a retired electronic technician and I'm a creator of Angelo project. I'm driven by curiosity and lateral thinking. Unfortunately, my English is not the best. Therefore, Sid will show you a slide that will me explaining the key points of this project. After my speech, Sergio will go into detail on the Angelo project and its future goals. Okay. Allora, Angelo device. I developed this device during the COVID pandemic to communicate with my father-in-law Angelo, who was 104 years old and had an hearing loss. Equalizer amplifier. The Angelo device selectively amplifies specific sound frequency, improving speech understanding and emotional perception for people with hearing loss. Emotional feedback. The emotional feedback from the experience with my father-in-law motivated me to release the project as open source, making it accessible to everyone. Free professional collaboration. The development of this project was possible thanks to the free exchange of knowledge and skills by different professionals. Inclusive solution. Over 1.5 billion people worldwide suffer from hearing loss, often associated with dementia. Angelo provides an affordable, customizable, and impactful hearing solution to millions of people around the world. Easy to assemble. The device can be assembled in minutes without any tools. Anyone can assemble Angelo. Goals. Angelo's primary goals is to bring joy and amplify emotion by improving communication around the world. My short speech ends here. Now Sergio will tell you in detail the project and his experience as Angelo Point. Now go Sergio, go. Bye.
Thank you so much for that intro, Luciano. And now we have Sergio here to kind of go into a little bit more detail on the Angelo project.
Yes, I can show you Angelo, first of all. It is a very simple thing, very little and cheap thing. It's an amplifier, an audio amplifier. So you can turn on, turn off, okay. And it's run with earphones. So inside it has a microphone, and it is thing for old people, elder people, but as told Luciano, is difficult to hear, and so they can listen better. And this is the Angelo device, but the important is the project Angelo. Angelo is the project that is for old people, is of attention, care of elderly people that mostly is lived alone with his problems, audio problems mainly, and it is a very cheap solution. The main part is around the PCB costs 10 euros, more or less than 10 euros. And all the project is open hardware, and there is a site. It is still in Italian language, but there are all the project, all the files you can send to JLC PCB to have the PCB inside ready. And also the cover is open. It is my project that can be easily opened. And this is the PCB. There is a battery, rechargeable batteries, but it runs only also with a 9 volts battery inside. This is the device, quite easy, and but very, very useful. And after we can give also a microphone, an external microphone that can be plugged in another jack, audio jack, so it can be more easy to be used where there is some noise around. And I have involved in this project by Luciano. He is a friend and his colleagues, retired colleagues of the company where I still am working. And I wanted to help him, his project, because it's very interesting. And not so much people is able to create all the system. So me and my son Diego propose the full system available. We send this and give a possibility to use this to the people that cannot, that is not able to create all these things. The cover is 3D printed and the PCB is ordered online, and other things are bought online. The whole system with earphones, microphone, rechargeable battery is around 40 euros, 40 euros of cost. And the last proposal, we have created a book to give to libraries where inside all the system. So people, we hope they will try this system, and if they think it is useful, they could do by themselves if they can, or ask to someone that are named Angelo Point. I am the Angelo Point of my city, that can give the full system for an honest price, a good price. And I think it's very, very useful, this problem, especially for low and middle income countries. And for this is very simple. No, we are thinking of some upgrade, such as Bluetooth systems, but for this we are continuing to have wires and simple, very simple and cheap system to be used for people that is not so smart, because they are old or they have some issues. And so in any case, the important is the project that starts from Luciano, that has found this difficulty of his father-in-law, and continue with people that take care of people that has some difficulty to stay in the family and socialize, because there are these problems that are common but not so known by normal people, and we want to help to solve this problem. I have started with 10 devices. I ordered the PCB online. After this, I have reordered 25 other ones, and near in the last Christmas, I have sold out all these ones, and now I have ordered other 50 systems with 50 PCB, and okay, I love to do this, to be helpful, and I hope that some other one will create this device, because I think the project behind is very important, and go to help people that has some problem, and it is important to be near with them, to help them, because normal devices are very expensive and not so easy to be used, are so sophisticated and so small that can be not so useful for old people. This is a very frugal innovation, but in lots of situation is very, very important.
Yeah, definitely. I remember going through the website, and there was a lot of talk about how hearing loss is very common, especially as you're starting to age. So something like this that is really streamlined, really simple, but really easy to hold, easy to use, especially for elderly folks who might not be so familiar with tech anymore, this is a really great solution. It's really, not only is it beautifully designed, I love the colorful covers. It's really fun. It's really such a simple way of being able to provide that access of like, it's a microphone, you've got the headphones, you can actually interact again, you're part of the conversation. That's so important. The website said that it kind of started off in Luciano, his father-in-law Angelo's care home. Are they still using it pretty frequently at the care home?
Sorry, not.
Oh, sorry. Do you, is it still getting a lot of use in Angelo's care home?
I am selling mainly to private person for their familiar, for their family,
Okay.
for the grandfather, grandmother, mainly for this. We have give someone to nursing house, and yes, but the main thing is that there must be someone that take care and help to use this one, because in Italy, where old people is in nursing homes, the personnel, the worker are maybe too much involved in following too much people, and so they are not so helpful in this. And there, yes, if someone, the most important thing is that someone take care of a person with these problems, and use Angelo and help to use Angelo, help these people to use Angelo. In this big center is useful, but the main important thing is to find someone that explain how to use and help these people that sometimes very has also problem in use his hands and to take Angelo and put on himself, and so it's Angelo is very powerful, is very useful, but there must to be someone that use it, help to use it, please.
Definitely easier when there's a support person who understands what's happening and how it can work. Yeah.
Yes, because if we give Angelo to an institution that has a lot of people with audio problems, but there is no one that take of shelf, it is not useful.
Mm-hmm.
So Angelo is the project, and the device named Angelo, but is useful. The main important thing is that someone take care of this kind of person or problem of issues.
Yeah, of course. It's so important to have that kind of care with our elderly folks. Like, I feel like this is such a good example of the ways that we can forget that our elderly need that kind of care, need that kind of support sometimes, and just giving them a device isn't always enough. Being there with them and helping them understand the device and use it with them, that's so important, especially with something like this where it is very simple to design, but you know, a lot of people don't know what a headphone jack is even. So being able to be like, okay, now you put this here and press this button and now we can talk easier is so important.
Yes. And today I have talked with a very, very big person, old, with audio problem, and it is a big issue because you cannot talk with them, and it's a big wall. And Angelo device, Angelo project is very, very important, and help to break this wall and to talk and to discuss and help to socialize is very important for also for us, not so for old people, but to both.
Yeah, absolutely. So I'm just going to bring Jana back on for a moment. And so thank you so much for coming on and telling us about the Angelo. Really excited to see how it grows and where it goes to next. I think hopefully we'll start to see it go beyond Italy and hit other countries as well.
Yes, we need to translate in English.
Well, maybe we can find some volunteers for that. That's the beauty of open source. We always like to have a community. So if folks feel like getting involved and doing a little help translating, this could be a really great project to get involved with.
Okay, thanks.
Thank you so much for being on today, folks.
Okay, thanks. Thanks for all. Thanks.
Thank you.
Thank you.
Grazie Sergio.
Ciao, ci sentiamo.
Okay, what a great show today. 3 really incredible projects. We're very excited to see where all these go next. So, and yeah, like I said, if you are interested in getting involved with the Angelo and helping them translate and getting it out there a little bit more in the English-speaking world as well, that would be a really great project to get in on if you're looking for something to do in the new year. We will be back again next month on February the 20th. I believe we'll be going back to the 1 p.m. EST start time for that. And again, don't forget to get your tickets for the Open Hardware Summit. And just a quick thank you, Snazzy, and thank you, George, for joining today. And for all you future folks watching, thanks for tuning in and finding out more about newly certified projects. See you next month.